Hi, Daniel here from Builderoo.com. I'm here with Dean from Linde. Could you tell me a little bit about Linde as a company?
Sure. Well, Linde is quite a big international industrial gases company. We've got about 55,000 people in the world, operating in over 100 countries. We're headquartered in Munich, but we have substantial business in the US, in Asia, in various locations in Europe and throughout Africa and into the Middle East as well. Solar for us is quite a major initiative in the for growth. We've been focusing on it over the last 4 or 5 years, and today we're supplying gases and chemicals to roughly about 50% of all the people in the world who are making solar panels.
Wow, that's very impressive. We're actually we're here to try to get a little bit of information about the chemicals themselves, because we know that photovoltaics can be big polluters when it comes to certain components. So could you tell me a little bit about how you're helping out with that?
Sure, yeah. Well, pollutants is a kind of emotive word. I think it's true to say that most of the gases and chemicals that are used in manufacturing of electronics generally, not just solar, have some hazards associated with them. And that ranges from things that you perhaps don't think about. Take for example, which come from air. They have their own hazards. For example, an atmosphere of pure nitrogen is, it's very dangerous because you can't breathe it, and 2 breaths of pure oxygen is all it takes to kill you. Two breaths of pure nitrogen is all it will take to asphyxiate you. Whereas pure oxygen also is very dangerous because it's an atmosphere that promotes fire. So the hazards associated with the gases in manufacturing range from the simple ones like that through materials like silane that burn spontaneously on contact with air, but are really not terribly significantly pollutive. They're a bit toxic. To gases like NF3, which is a significant global warming gas. And I guess that's really perhaps what you think of when you talk about pollutants. So NF3 is an interesting case in point. It's used in large amount by the thin film solar manufacturing industry. NF3 in its basic form is about 17,000 times more significant as a global warming gas than CO2. So you can imagine that for every kilo of NF3 that gets released out of the back of the manufacturing process, it's got an equivalent impact of 17 tons of CO2. And the consumption of a very large fab might be as much as anything up to 1,000 tons a year of CO2 of NF3 going in. Now, of course, most of it doesn't get emitted, and it's not anything like as serious as multiplying 1,000 by 17,000. However, there is a material that Linde has developed or is pioneering, the change in this industry. So we're converting fabs from using this highly global warming gas NF3 to an alternative material called fluorine, which is just a standard element, which does exactly the same job. In fact, it does a better job. The job of NF3 is to clean the chambers, and that's part of the production process. Fluorine works faster. You use less. It costs less, but the real beauty is, if in number terms, CO2 has a global warming potential of 1, NF3 has a global warming potential of 17,000, and fluorine has a global warming potential of 0. So it's an engineering solution. We design out global warming from the manufacturing process at the most fundamental level.
Okay, well that's very impressive. Are there any other ways that you're helping with solar manufacturing in eco-friendly ways?
Yeah, absolutely. The thing that characterizes solar manufacturing really is scale. So in almost every material that you use, the quantities that are being consumed are almost unlike anything you've ever seen before. So another good example that kind of brings this into focus is there's a chemical that's used in monocrystalline production. I mean, the function is it's part of the process that's used to create the appropriate texture on the surface of the wafer so that the light doesn't get reflected. And it's called KOH, potassium hydroxide. Now, there's a bit of a shortage in the world around potassium at the moment. And the growth of the solar industry in recent years means that solar now is a reasonably meaningful amount of consumption of KOH in the world. The other main use of potassium is in the production of fertilizers. So we have this situation where the growing solar industry is potentially coming into conflict with the food chain. And you can imagine there's some issue associated with that.
Sure.
The other thing that is of interest, other thing that brought it to our attention is that the efficiency of use of this material is very low. So only 2 or 3% of the chemical that goes in actually gets consumed in the process. The rest of it is it comes out in the wastewater, which means that there's a very high cost of treatment for that waste. But even when treated, you still find yourself with a wastewater stream that has characteristics that are not exactly desirable. There's this, you may have heard this term, chemical oxygen depletion, COD. Yes. So even when treated, this wastewater is prone to cause chemical oxygen depletion.
Could you explain that a little bit? I might know, but a lot of people might not.
Sure. So basically, the properties are that the chemicals in the water are such that they deplete the oxygen that you get naturally in the water supply, and the oxygen is the source of fish life. It also promotes the growth of things like algal bloom, which further depletes the oxygen level in the water, and therefore if you release a significant amount of this treated water into the natural water ecosystem, you get a significant increase in the growth of algae and algal bloom, and the consequence of that is that you get a significant drop off in the amount of fish life in the water. So our solution is that the combination of quantity and shortage in material, plus the negative implications of even treating it and releasing it, it kind of makes it an obvious candidate for recycling. So right now we're working with a couple of our customers around the world to basically recycle all of the KOH that's going into the production facilities. And this is a relatively new approach, even though it's quite obvious. I mean, recycling is a difficult thing to make work from a practical point of view. There's some concerns about getting the right quality back into the process, and managing the shipping lines, and the kind of regeneration of the material is non-trivial. But so far, the process that we're trialing in Asia is working quite well, and we're just about to roll it out on a kind of larger scale basis, where we're going to do the same thing for an entire new fab.
Oh, well, that's very impressive. And I don't know a lot about solar construction, I guess, but would you say that are those two of the biggest polluting chemicals in it? The KOH and the other one?
You have to look at things from a volumetric, in volumetric terms, and they are two of the largest volume chemicals that are used. From an emissions perspective, NF3 is by far the largest volume high global warming gas that is used. There are some technologies that use another gas called SF6, which has an even higher global warming potential, but it's used in much lower quantities. So SF6 is an interesting subject actually for us as well. It's used more commonly in the TFT LCD industry, where it has a kind of very interesting function in etching the device shapes. So it's very, very common there, and we're working in that industry to recycle the SF6 that's coming out.
Okay.
These kind of gases, they serve a valuable purpose, or mostly they serve a valuable purpose, and some of them can't be easily replaced. But what we find is that some of these more stable gases, even though their use may continue to propagate, they're often they can be mitigated by approaches to recycling. And recycling doesn't work everywhere, but we have a program actually to investigate all of the areas that we can target specific materials that have hazards associated with them, where recycling is viable without damaging the process. So ultimately, it has to make sense on both sides. It has to make sense from an environmental perspective, but also the economics have to work. At the moment, we don't have a cap and trade scheme in place. This is kind of preparation for when we do. But even now, we think environmentally sustainable manufacturing is viable in around many materials, without the pressure of a serious cap and trade driver for it.
Sure. Well, thank you. Where would I be able to find more information about the Linde Group?
Well, we have a standard website, www.linde.com, and once you get into that website, if you want more specific information about electronics or about our solar division, you can just click through to our electronics microsite, and you'll find, I think, most of what you need there.
All right. Thank you very much.
Okay.
And thank you for watching Buildaroo.com.